All right, guys, welcome to day 2 for our semester 1 final review. Today we're going to go over transformations. So before I start getting into the odd problems, I would like to review with you guys some of the basics about transformations. So if you have a function, we'll call it f of x, you can do things to this function that will change the shape of the graph. So one thing you could do is you could multiply the function by a number in the front of it. If you do that, we call that the a number. If a is negative, it reflects it across the x-axis. In other words, it flips it upside down. If the absolute value of that number, meaning just ignore the negative if there is one, the absolute value of that number, if it's greater than 1, then it stretches your graph. It makes it look taller. And if it's less than 1, it's a vertical compression. It'll make it look shorter. Another way we could change the graph is by multiplying inside the parentheses by a number, which we'll call b. If b is positive, it reflects it across the y-axis, meaning it flips it horizontally. If the absolute value of b is greater than 1, it will squish the graph so it looks skinnier. And if it's less than 1, it will stretch it so it looks wider. Another thing that we could do is the x could have a number either added or subtracted from it, and we call that the h. If you're adding a number to x, it translates or moves your graph to the left. If you subtract a number, it moves your graph to the right, that many spaces. Finally, if you add or subtract a number outside the parentheses, we call that a k. If it's a negative k, it translates it down. In other words, it just moves or slides the graph downwards. If it's a positive k, it translates it up. Now, before I get into the exercises, one more thing. There are two ways then that we can make a graph look skinnier. One way you can make a graph look skinnier is by compressing it horizontally like this. Okay? And if we look back at our last slide, a horizontal compression means that b is greater than 1. So that's one way that you can make your graph look skinnier, is if the b value is less than 1. Now let me put this back the way that it was. Another way that you can make it look skinnier is you could stretch it vertically. That looks skinnier. It's bigger, but it's still skinny. So we can also stretch it vertically to make it look skinny. And if we go back to the last slide, a vertical stretch is when a is greater than 1. I had this one backwards, actually. This was supposed to be greater than 1, my bad. So if you want your graph to look skinnier, then either the a or the b have to be greater than 1. The absolute value of a or b has to be greater than 1. Okay. Now, how can we make our graph look wider? One way you can make it look wider is by stretching it horizontally. So going back to here, a horizontal stretch means that b is less than 1. B is less than 1, or not b itself, but the absolute value of b is less than 1. Another way that you can make your graph look wider is by taking your graph and squishing it this way. That makes it look wider as well. And so that's a vertical compression. So if we go back to the last slide, a vertical compression is when a is less than 1. The absolute value of a is less than 1. So there's two ways to make your graph look skinny, and there's two ways to make it look wide. The two ways to make it look skinny is if the b or a value, the absolute value of b or a, is greater than 1. The two ways to make your graph look wide is if the absolute value of b or a is less than 1. All right, so knowing that, I think we're ready to go ahead and jump into the exercises, and we'll probably be referencing back to this page here quite a bit. Let's begin. Right. So here's our first question here. This one says, describe the transformation necessary to transform the graph of f into that of g. All right, so here's f. Let me bring up my pen really quick. Here's f, and here's g. Now notice that there's a number here outside of the square root. That would be the a value. Okay. Notice that we have a -1 on the inside here. I think I'll make it purple, multiplying the x. So that would be my b value. And then finally, we have a +1 being added to the x there. That would be my h value. Okay. Now, if we look back at our little sheet that we wrote down, first of all, notice that a is positive. So it's not going to be reflected across the x-axis. But the absolute value of a is less than 1, which means our graph is going to be vertically compressed. In other words, it will end up looking a little bit wider. The next one is we have b is equal to -1. And when b is negative, that means we have a horizontal reflection, or in other words, we say it's reflected across the y-axis. Now, the absolute value of b is 1, and that equals 1. So it's not less than 1, it's not greater than 1. So we're not going to say that there's a stretch or a compression horizontally. It's just equals 1, so it stays that way. Next, we have h. H is a +1, and when that happens, we have a translation to the right. Okay, so we're looking for the option that has those three criteria in it: a vertical compression, a reflection across the y-axis, and a translation to the right. And we could see that the answer choice that satisfies that criteria is option, where did it go? D, reflection across the y-axis, compression vertically, translation to the left. Oh, did I say translation to the right? I did, didn't I? So I was wrong. This is supposed to be a translation to the left. My bad. Because it's a positive. When you add one, it's a translation to the left. So there's that. All right, let's take a look at another one here. I'll let you guys do the even ones. Okay, so for this one, we have a number outside of the square root. That's my a value. We do not have a b value this time, but we do have an h value here. I'll put +3. And we also have a k value. That's different than last time. K is the number that's being added or subtracted outside of the parentheses. Okay. So first of all, let's start off with a. So notice that a is positive, and since a is positive, there's no reflection here. But the absolute value of this number is greater than 1, which means that we have a vertical stretch. Next, notice that my h is a +3, so that means we're going to have a translation to the left again. And notice that my k is positive. That means we're going to have a translation up. And so the answer there would be option B. Now they're using the word expand instead of stretch, but it's the same word. So we have a vertical expansion by a factor of 3, a translation to the left, and a translation up. Notice also they're including the numbers here, the 3s. You can do that too. All right. Moving along to our next question. Number 5. So far we've seen absolute value functions come into play here, but I'm sorry, square root functions, but this time we have an absolute value function. But the same principles apply. It's not a big deal. So First of all, the only thing that we have here is we have an A. The A is negative 1/3. Now notice that my A is negative. That means that we do have a reflection across the x-axis since my A is negative. And if I take the absolute value of that, meaning ignore the negative, just make it 1/3, that's less than 1. And so that means we have a vertical compression. So we're looking for the option that talks about a reflection across the x-axis, and it is a vertical compression. Okay, and so that looks like it would be option B there. This is another way of asking the question, only this time we're doing it with graphs. Okay, and back when we did this a while ago, I suggested that you guys interpret this a little bit differently. I said, think of the instructions as, what would you have to do to the blue line to get the green line? Or you could say solid instead of blue. Maybe on a test paper it's going to be black and white. Green would be the dotted one. So just think of the instructions that way instead. What would we have to do to the blue line to get it to look like the green line? Well, I'm going to trace it really quick in blue. There it is. So what would I have to do to that blue line there to get it to look like the green? Well, first of all, I'd have to reflect it. I'd have to flip it horizontally. So to flip it horizontally, it would look like this. Oops. But that's still not quite correct. I would also need to slide it up. And I've got to come to my computer for that. There it is. And now it matches the green line. So we would need to flip it horizontally, or in other words, reflect it across the y-axis. And then we would also have to translate it up. Okay, now if I'm reflecting across the y-axis, that means that my B is negative. And if I'm translating it up, that means my K is positive. So we're looking for an option that has a negative B and a positive K, and that would be option D. Go ahead and take a look at another one. So same thing. What would I have to do to the blue line to get it to look like the green line? Well, first of all, I would have to flip it upside down. So we have a vertical reflection, also known as a reflection across the x-axis. The next thing I would have to do to get those to match is I would have to slide the graph over 3 spaces to the right. But it's still not a perfect match. It looks like we need to change a little bit, but still we translated it to the right. Okay. Now the last thing I need to do is I need to make that graph look what would that be? I would need to stretch that graph vertically. Or we could try squishing it this way. That would also make them look. So it's either going to be a vertical stretch or it's going to be a horizontal compression. It's going to be one or the other, either a vertical stretch or a horizontal compression. It could be either one. Okay. Now, for the vertical stretch, that means that the absolute value of A is greater than 1. For the horizontal compression, that means that B is greater than 1. So it's one of those. Either the A is bigger than 1 or the B is greater than 1. The translation to the right means that H is negative, and the reflection across the x-axis means that A is negative. So we're looking for a problem that has a negative A. So that means this can't be the answer. We're looking for one where the H is negative. So this one doesn't have an H, so we can get rid of that. So both of these have an A that is negative and H that is negative. And vertical stretch, the absolute value of A needs to be greater than 1. Now, here's the problem. Both of these are greater than 1. So now in your test, I won't give you one that's that ambiguous. It's kind of difficult to tell. But if you took the absolute value of either one of these, they're both greater than 1. So how do we know which one it is? Well, it just kind of depends on how big the stretch is. As you guys can see, from here to here, I go over 1 up 1. Here, to get from here to the next point, it's over 1 down 2. So it got stretched twice as much, so we would say A. Now on the test, I'm not going to ask you guys to have to pick between two like that. It'll be obvious. I wouldn't include a third option that could confuse it, but it's worth mentioning there anyway. Let's go ahead and take a look at one more of these types of questions. What would I have to do to the blue line to get the green line? Well, first of all, obviously, I'd have to flip it upside down. Now, if I flipped it upside down, it's going to look like this. But that's still not enough. But let's go ahead and write that down. So that is a reflection across the x-axis. Flips it upside down. And the next thing I want to do is I want to squish it inwards. Okay, so there's a couple, once again, there's two ways that that can happen. Oops. One way is we could make it skinnier like that. So I could compress it horizontally. Compression horizontally. Another way we could do this is if we take it and we stretch it vertically, that'll also make it match. So it's either a horizontal compression or it's a vertical stretch. It's either a horizontal compression or a vertical stretch. In this case, the horizontal compression, that would mean that the B value is greater than 1, the absolute value of B. And in this case, the absolute value of A would be greater than 1. Finally, reflection across the x-axis means that the A is negative. So we're looking for a negative A, first of all. So that gets rid of option A there. The rest of them all have a negative A value. Next, we want to find one where the absolute the A value is greater than 1. Both of these have an A value of 1, so those are no good. And this is the only one that has an A value that's greater than 1. And it looks like they didn't need the B value on this one. So remember, it doesn't have to be both of these. It could be one or the other. In this case, it was this one. Right? And that'll do it for our transformation. We'll move on to the next part of the study guide here. All right. So this says evaluate each function. What this means is we're going to plug this number in for x. There we go. I'm going to go through and I'm going to replace all the x's with 4. And then we're going to simplify. 4 to the third power is 64. 4 times 3 is 12. Adding those those together, we get 76. All done. Number 15 is a little bit different though. Number 3 is asking us to solve. It says find x. Actually, I should say find t. It says find t if w of x equals 3. That means I'm going to replace not x, but w of x with 3, and then we're going to solve for t. So I'm going to replace this whole thing here, w of at t, with 3, and then we solve for t. And there's that. And that's that. And that'll do it for our review for today. All right, guys, hopefully that was helpful, and we'll see you guys later.